Hello everyone, welcome back to the channel. In this video, we will talk about MCP, which is Model Context Protocol. But before we start this video, let me just take you back to this playlist here. So this playlist is basically I'm putting all the videos on LangGraph. So you'll find different concepts, all the concepts of LangGraph with some code in each of these videos. So you'll see both the conceptual part and the coding part in all of these videos. So I'll be putting more and more videos in this playlist. So this video is also going to be part of this playlist. Along with this, if you want to try the code yourself, do some hands-on, so you can go to this Git repository where I'm putting all the codes from this particular playlist. So with this quick background, let us get back to the topic. So in this video, we'll be talking about MCP, which is Model Context Protocol. So to start with, first of all, what is Model Context Protocol? So Model Context Protocol is like it's like a common language or a connector that helps an AI, right? Like it can be any assistant which we use usually, like ChatGPT or Claude, to talk to other apps, databases, or tools, right? So it's like a common language or a connector using which we can connect our assistant to various tools, like various apps, databases, or uh, different types of resources. It makes it easy for AI to access information from different sources like Google Drive, Slack, or a database, right? Without writing different code for each one, right? So these are just few examples. There are a whole lot of MCP servers which can be used to connect to various tools and various resources, various document connecting servers, right? So in this video, we'll see some real life analogies, some real life examples on how we can use MCP, what exactly MCP is, what are the components of MCP, and then um, we'll also see a simple project using MCP where we'll be building MCP servers and we'll be building MCP clients to show how exactly this connection works, right? So the first real life analogy is here a juice dispenser system, right? So imagine that we are at a juice bar. Imagine that we are a juice bar. So there is one main tap, and behind the counter, that tap is connected to an orange juice container, mango juice container, or a pineapple juice container, right? So we have this one main tap. Behind, we have three different containers here. So now, what do? We just press the button and the juice we want comes out. We don't bother about knowing how exactly this entire system looks like in the background. We don't need to know how the pipes work, right? So similarly, MCP is like that tap system for AI. It helps the juice, that is information from different containers, sources like databases or apps, without knowing how each container works inside, right? So it is just this MCP is just like this main tab here. So when we use MCP, we don't need to know how these pipes are connected, from where this orange juice is coming, from which pipe this mango juice is coming, from which pipe this pineapple juice is coming, right? We just need to press this button and we get the juice. So these different containers in the background are like different tools, right? Different, it can be different apps, different functions, different databases, different data sources, right? And we just use the MCP to connect these different sources to our main assistant, to our main application, right? So now we'll see how or why is MCP useful. So let me just scroll down. So without MCP, how would we handle this kind of a problem statement? So without MCP here, we need to build custom tools or custom code for each juice container here. These juice containers are nothing but different tools like Google Drive, Slack, Notion, etc. So we need to write different codes, right, for each of these tools. So just imagine how messy it gets, writing so many codes for each and every tool. So here we are just talking about three tools. Imagine we need 50 tools in our AI application. Then we'll be writing 50 different integration codes, for each of these tools. So this creates a lot of mess. This takes a lot of time and effort, right, to maintain and also to write. So now with MCP, we just build the tap, right? We just build the tap once. That is the main tap. Now AI can get any kind of juice or any kind of, it can use any kind of tools from any of the containers as long as the container follows the MCP standard, right? So this was one simple example, simple real life analogy to understand how this MCP works and why do we actually need MCP? What is the real business need for MCP, right? Now we'll see another simple example. So let's say we that you need to build a college assistant AI that answers questions using using your lecture notes on Google Drive, pulls events from your college calendar, sends you reminders on Slack. So there are three types of tool being used here. Tool number one is Google Drive. Tools are applications, right? Tool number two is calendar. Tool number three is Slack. So to integrate these tools into this assistant AI or AI assistant, we need to write different codes for this, right? So that's what we need to write different code for each app, correct? Now with MCP, you connect with your assistant to an MCP client, and then each app connects through an MCP server. The assistant just talks to MCP and gets everything it needs, right? So it just smoothens out the entire process. It reduces the complexity here. So we just need to connect our assistant to the MCP client. MCP client is in turn connected to a whole lot of MCP servers. These MCP servers will be having all these tools, Google Drive, Calendar, Slack, or so on, right? And then the assistant just needs to talk to the MCP and gets everything it needs, right? So it reduces the complexity. Now let's talk about how it works in a very simplified way, right? So this MCP server is nothing but it is a server which connects to a source, right? It is a you can say it is a code. It can be a piece of code, or it can be any any tool which can be used for connectivity. It connects to a source or a tool like Google Drive, Slack, etc. Right? What is MCP client? MCP client connects the AI to all those servers. MCP client connects the AI to all those servers, which is the MCP servers. And these tools are nothing but functions the AI can use, like Google Drive, search Google Drive tool, or a read calendar event tool, and etc. Right? So just a tip here, how to remember it, right? So just consider MCP as USB for AI. So your laptops will be having the USB port, right? So it's like a MCP is like a USB for AI. Why USB? Because you plug in different types of tools to the USB in your laptop or in your computer, right? For example, you plug in your mouse, keyboard, a phone charger, etc., and it works, right? Similarly, you don't need a new port for every device. The various devices are there, mouse is there, keyboard is there, and a USB port works for all these devices. We don't need to create a new port for every device. So the similar thing MCP does for AI. One connection works with many data sources, right? So this MCP is nothing, but it's like a USB for AI. So now let's take a quick recap. So first of all, what is MCP? So MCP is like the USB port or the juice tap, right? The main juice tap, which we discussed above. And MCP server is like the juice containers or app connectors. So various containers, right? They are the MCP servers, right? Inside that we have different tools. Like we have in one we have orange juice, in one we have mango juice, right? But these containers are the servers. Servers will contain different tools like search nodes, get calendar, like these various functions of various tools, right? The MCP client is the tap system or the interface which helps us to get the various juices, right, from various servers, which are the containers. So these MCP clients are the tap system. Okay, now let's see a diagrammatic view um, of this entire flow. So there are, let's say, there are various external services, right? So we have an external source, which is Google Drive. Another one is Slack. Another one is database, right? And these tools or these external services are part of this servers, right? So these servers contain these tools. So here we have only one tool or one application. We can have many more in a particular server. So in one MCP server, we can have multiple tools, right? So similarly, we have a server for Slack, we have a server for database. All of these servers interact with this MCP client, right? And this MCP client basically fetches the information from this MCP servers based on the user query. And this in turn, this MCP client is connected with the AI application. This application can be anything. This can be a Python code. This can be a assistant built by you. This can be a chatbot, a virtual assistant, right? This can be anything. So this was the pictorial view of what we discussed above, right? So now let's see an explanation. So these external services, basically, these are various tools and data sources like Google Drive, Slack, or databases that contain information the AI application might need. These MCP servers are basically each external service has a corresponding MCP server that acts as a bridge. This is the important word. This MCP server acts as a bridge, basically, translating the services data into a standardized format. For example, an MCP server for Google Drive fetches documents. An MCP server for Slack retrieves messages. Similarly, an MCP server for database accesses specific records, right? So this MCP server acts as a bridge, right, between MCP client and the external services or external tools. The MCP client is nothing but this is integrated within the AI application. The MCP client communicates with multiple servers, right? So this basically MCP client is used to communicate with the MCP servers. It sends requests to these servers and gathers the fetched data. It sends requests to these servers and gathers the fetched data, right? And then the application is basically, this is the main application, right? Such as the chatbot or a virtual assistant that utilizes the data obtained via the MCP client to provide informed responses or actions. So this is the application. This is the user interface which you are using to, carry on all these communication happening in the background, right? So, so in the AI application, the user might give a query, then this client basically sends this query to the MCP server. It retrieves or gets back the response from the MCP server, and then again communicates it back to the user on the user interface. Okay, so now let's see an analogy here, right? So um, let's imagine that let's imagine the AI application as a universal remote control. Okay, let's imagine the AI application as a universal remote control. External services are like different entertainment devices, like TV, DVD player, sound system. MCP servers are the individual receivers connected to each device, interpreting signals from the remote, right? MCP client is the central system within the remote that sends out signals to the appropriate receivers, right? So this MCP client is going to send out appropriate signals to specific servers, right? And this AI application is basically you using the remote to control all devices seamlessly. Okay, so this is another analogy using which you can understand, basically how MCP works. So this setup allows the AI application to interact with various services effortlessly, much like how a universal remote control multiple devices without needing separate remotes for each. By adopting MCP, developers can integrate AI systems with multiple data sources in a standardized and efficient manner, reducing the complexity of custom integrations for each device. Okay, so this was the conclusion. Now let's see another diagram here to understand the code which we are going to discuss next, right? So this is the project which we have. This is a sample project which in which we will create two different servers, and then we'll create client to use this two different servers, right? So the first tool, the first server will have two tools. This is the number one. This tool is basically for reversing a string. So and the second tool is basically to count the number of words in a sentence. So second server has two tools. The first one is which gives the current date and time. The second one is basically this returns the current. So second one is this one, which is the days until tool. This calculates how many days are left until a given date. So these two are the servers, and each of these server have two different tools, right? This one and this one. And then these two servers are again connected to MCP client. So this MCP client communicates with these two servers and gives us the response back as on the AI assistant, right? So this is the sample project which we'll be discussing next, after this theoretical explanation. So this was all from the theoretical aspect of MCP. So we have seen, just to give a quick recap, we have seen what is MCP, how it is useful. We have seen a couple of real life analogies. We have seen some examples, right, to understand, how basically this MCP server client communication takes place. And then we have also seen some diagrams to understand it better. Now, based on this particular diagram, we'll see the code in which we have implemented this particular flow here, right? So now let's quickly go to the code part here. So here we have, first of all, the first server is the strings tool server, right? So this particular server has two tools. The first one is reverse string tool. The second one is count words tool, right? But one thing to note here is that we are using MCP server fast MCP, right? We are using fast MCP to create this server. So to use this, first of all, we need to install fast MCP, right? Once we install fastMCP by this command pip install fastMCP, then we can import this particular fastMCP from MCP server fastMCP, right? And then we have to create this particular variable, right? And then we have to give this decorator at the rate mcp.tool, and then we have two different tools, reverse string tool and then count words tool. This decorator is important, and at the last we are running this particular file. So to run this, we just give Python, Python and then the file name, right? So now this tool is running, right? The moment we give this command Python and this file name, this starts running. You'll not see any output here as of now. You'll not see any prompt or any output at this point when you run the server. So now once the server is up and running, now let's see, we have another code in which we are creating a client for the single server, which is a string tool server, right? Next, we'll also see a multi-server client. So here again, we are using LangChain MCP adapters here, right? For this particular client code. So to use this, we have to give pip install LangChain MCP adapters. So then we are again importing the required libraries, async.io from MCP. We are importing client session, stdio server parameters, right, and so on. We are using Ollama here, and the model is Llama 3.2 for this particular code. So once we are done with this, here we define the server parameters. We give the command here Python, and then we give this our tool name, sorry, our server name basically, which is string tool server py, and then we write the further code, right? So first of all, we say load mcp tools using this session. First of all, we initialize this session, and then we then we create this variable tools, and then we use this load mcp tools function, and then we basically pass on all the tools here, correct? And we are also using this create react agent module from LangGraph pre-built. So this is a react agent. So this works in a particular flow which we have already discussed in another video on this in this playlist, where it basically takes that loop where it thinks, takes action, observes, and then again it thinks until it gets the satisfactory answer. This loop goes on, right? So we are using the same agent here, create react agent. We are passing on the model, we're passing on the tools here, right? These tools are coming from this server, right? Which we are passing as a server params here, right? So we have all the tools defined in this particular server. Now we are giving the input, right? The first input is reverse the string hello world. The second one is how many words are there in the sentence. Model context protocol is powerful, right? So one by one we are implementing or invoking both of these inputs. So if we just run this particular, uh, let's say we run this particular client here, so we'll see the output soon. Okay, so now let me just expand this. So first of all, it takes on the first question, reverse the string hello world. Then it calls a tool. It calls the tool reverse string tool, right, which we define, and then it reverses that particular string. Then it gives the final answer. This is the AI message. Here is the answer to your question. The reverse string of hello world is this one, right? Then it takes the second question. How many words are in the sentence? Model context protocol is powerful, right? So the number of words is 5. Here it uses another tool, which is the count words tool. And again, we have both of these tools here defined in this particular server. Reverse string tool is this one, right? Then we have count words tool here. So here, for the first question, this client uses the reverse string tool, and then for the second question, it uses the count words tool. And here it decides automatically, which tool needs to be used for a particular query from the user, right? So this is a single server client using Ollama, right? Now, next we'll see multiple server client using Ollama. So for that, we'll define another server here. So again, we need to pip install fast MCP here. Then we need to import datetime from datetime. Then again, we need to import fast MCP. Then we create this MCP, basically MCP server here. Then we add two tools here. The first tool gives the current datetime. The second tool gives the, returns the number of days from today until a future date, right? Right. So this is a simple code here. So this particular server datetime tool server also has two tools which we'll be using in this particular client, in which we'll see how to use multiple servers in a client, right? So this is another server, datetime tool server. Now let's move on to the client here. So here, to use multiple servers, we need to import multi-server MCP client here from LangChain MCP adapters, and then we'll again follow the same flow. Here we will define the basically parameters here. That is, we'll define the various servers we have. The first one is string tool server.py. The second one is datetime tool server.py, right? And both of these servers have two tools each, right? And then again, we'll create this React agent here using LangGraph pre-built, right? And then again, we are asking three questions one by one. The first question is reverse the string, LangGraph and MCP are cool. So in this particular query, we need to use the reverse string tool from this string tool server. And the second question is what is the current date and time. So for this one, we need to use current date time tool from this particular server. And then finally, we have how many days until this particular date. So for this one, we need to use this days until tool from this date time tool server, right? So this will be automatically decided which tool needs to be used for which particular query. Then again, we invoke these queries one by one, and we'll print these in a way that we'll see which tool is being used for which particular query. So now let's run the multi-server client, this code basically using Ollama. Okay, so this will take a few seconds. Okay, so let's see the output one by one here now. So the first question was reverse the string, LangGraph and MCP are cool. So for this, it uses the reverse string tool, right? It automatically decides, the LLM automatically decides which tool needs to be used. And these tools are provided by these servers, right? So it uses the reverse string tool, and this basically reverses this particular string, right? So it gives the answer. The reverse string is this particular string. Then the second question is what is the current date and time? So for this one, it needs current date time tool. So it uses current date time tool and it returns the answer here, right? This particular answer. The current date is April 6, 2025, and it also gives the time, the current time. So the next question is how many days until this particular date, right? So for this one, it uses this days until tool, and it returns the answer 268. So it says, the answer to the user's question is there are 268 days until December 31, 2025, right? So here we saw how we can use multiple servers, um, you know, which can have multiple tools. So one server can have multiple tools, and we can use these multiple servers. So we can create a multi-server client to use this multiple servers. So this was all for this video. I think we have covered entire concept of MCP using various analogies, various real life examples, simplified examples, and then we also saw we also saw the code where we created a simple project where we first of all did a single server implementation, and then we also saw a multi-server implementation using Ollama. So this was all for this video. So I'll be putting this video in this particular playlist. Feel free to get the code from this repository, right? So you can see this. I've already put this code here, so you can just try these codes, try to change it or modify it according to your need, and you can play around with these codes, right? So I'll see you soon in the next video. So till then, thank you for watching this video. Subscribe the channel if you like the video, and share this video with your friends so that maximum people can benefit from this. Thank you.